Hi everyone, I'm Mohammad Adain. I'm a second year master's student here in computational sciences and engineering with a specialization in high performance computing systems, and a little bit of interest in cybersecurity. And before starting my master's, I worked for 3.5 years as a senior software engineer on the infrastructure and systems team at RCCM shop. So that's where I got to use Kerberos, so hence the talk. So yeah, let's get started, I guess. Today we'll not only be discussing about Kerberos, but also we'll try to design an authentication system from scratch. Not just designing it from scratch, we'll design it from an attacker's point of view. The way we're going to do it is, we'll be playing a cat and mouse game where, we'll come up with a solution and try to break that, and then build our solution, trying to mitigate the vulnerabilities which we discovered. So yeah, I mean, so this I plan to make this an interactive session. So your involvement is highly recommended. Uh, so yes, so the goal here is to design an authentication in a time distributed, time sharing system where you have multiple clients which are trying to access various resources and servers. And then, of course, the servers should know the true identity of the clients for them to actually, serve the request to the clients. And again, just to make this sure, we'll be designing the system from an attacker's point of view, so that we come up with a good system which would try to be secure. So yeah, to set a premise, right, we have clients on the bottom, Eve, Bob, Alice, and then we have various servers on the top which the clients are trying to get service from. So as a rudimentary sort of thing, right, like when Bob tries to get his mail from the mail server, Bob asks for the access to the mail to his mailbox, and then of course the mail server will ask Bob to prove its identity. So one very basic approach over here would be, Bob providing its password to the mail server, and mail server would validate that password, and then if the password is validated, it will start processing that request. But then, of course, this is a very simple solution, and then, does anyone want to take a guess at what the issues are? I mean, this is a very vulnerable system, so like, yeah.
One sits in the middle and intercepts all traffic.
Yes, yes, that's good. And then what else? There's one other very obvious issue here. Like, yeah.
Someone just knows a password that they can just log in from a different device.
I mean, let's assume the password is only known by the client to start with. Yeah. There's one very important issue which you can relate to the MCP servers. If you can think of it, because you have so many clients and so many servers. So the issue is the number of passwords, right? It's in the complexity of the number of clients into number of servers, and maintaining so many passwords is not a trivial task, right? Password management and stuff like that. This is what the MCP server also tries to do, right? Instead of making it creating the number of agents into number of LLM integrations, you just have to create the number of agents plus number of LLM integrations. And then, yeah.
Okay, sorry, finish the slide and I have a question.
Sure. And then, yeah, of course, every server will have to go ahead and do a validation check on its end for the password, right? Because, your mail server will also have to have that validation, password validation logic, the printer, the web server, and every other server here would have to have the validation logic. And then the server itself can be a client for some other service, right? So there are so many more passwords. Yeah, website.
So to ask about the OOC times S passwords in the system, I'm assuming C refers to clients and S refers to server.
Yes.
Which part of the system cares about the total number of passwords in the system? Like, I'm assuming like maybe the servers would, they have to account for however many like client passwords they have to save. But even in that case, wouldn't each server only have to care about OOC?
That's a good question. Actually, that's the total number of passwords that are in the system, right? So like you need to make sure like each of them are actually updated periodically and stuff like that. So of course, like you
Like
know,
from a system administration perspective.
yes, exactly,
Okay.
exactly. And then like if you have one more server which is added or one more client which is added, you'll have to add those many passwords in. So like it doesn't scale.
That makes sense.
So yeah, we'll introduce Sharon, a centralized authentication server. Just for background context, right? In Greek mythology, Sharon was a ferryman who carried souls across the river Styx, which essentially was the river which separated the dead and alive. You'll see how this relates to our authentication system in a while. But then yeah, uh, here so instead of each server having to do the authentication, we separate all of that logic out to a central authentication server, in our case which is Sharon. And then instead of the client passing on the password to the mail server, it will instead request a ticket from Sharon for it to access the mail server. This way, the mail servers and all the other servers don't have to worry about validating the password itself, because this ticket is encrypted by mail server's password, which is only known to the mail server and the authentication server, which is Sharon over here. So the ticket essentially looks like that, which essentially is a tuple of username and the service name. So username in this case would be Bob, and service name would be the mail server. And then Bob is just a relay over here. It fetches that request, but it can't actually see what's inside that ticket because that is issued by Sharon, and because it's encrypted by the mail server's password, it cannot decrypt it. And then it just passes it on to mail server as part of its request, and the mail server decrypts that request and checks if the username in the ticket is same as the username of the request that was originated from the client. And then the service name has to match to the service name for which this particular ticket is intended, right? This helps us reduce the password management to a significant extent. But then again, you have issues with this. So, like, does anyone want to take a guess? Yes. Yes.
Like the same thing as before, where anyone can impersonate Sharon and get the username and the password, and then to forward that onto the real Sharon and get the token, or they could impersonate a mail server, intercept a token, and then just reuse that token for other stuff.
Yes, exactly.
So got it.
Yes, exactly. Right. And then there's one more other issue over
Mind
here.
reiterating what Nash said, just for the people online?
So with that,
Would you mind reiterating what Nash said?
you want to repeat?
Yeah, I just said like a man in the middle attack, where someone pretends to be one of the servers and intercepts the credentials.
Yes, that's one issue. And then there's one more issue here. Obviously, you have the password still is being transmitted in plain text over here. So, because for Bob to get a ticket from Sharon, it needs to prove that it itself is Bob. So the only way it can do that is by giving Sharon the password, and of course the man in the middle attack. And then there's one more issue with this thing. So if you look at it, right, if Bob wants to access the mail server, say 100 times a day, he'll have to punch in his password 100 times to get the mail ticket for the mail server, which is not very pleasant. Yeah.
Token only one time use.
Yes, as of now. As of now. That's improvement which we'll be doing.
So the mail server is tracking which tokens have already been used. How does it know it's only one time use?
Well, because
Because you could, if you sent the token once to the mail server and it tracks the token, if you could all send to the web server, let us know the token's been used, right?
that's a good question. So, like for instance, right, if the mail server would probably maintain a log of the tickets which are actually used, and then if it sees that the ticket is already used, it would just discard it because it's used for the second time. But that's a good question. Yes. So that way. So yes, and then uh, this. So yes, you'll have to punch in your password like those many times as to how many number of times you're supposed to use that. And then like one very important point that we have to discuss over here is that instead of giving the ticket, right? Why can't Sharon just give Bob the password to mail server, right? Like once it gets the password to the mail server, it can just make a request to mail server with its password, and then it can, authenticate itself. The reason why that doesn't we don't allow that is because that way Bob can like bypass Sharon altogether, right? Because if Sharon gives Bob the password to mail server, the next time Bob has to make a request to the mail server, we'll just reuse that password, right? So like, and then what if that password is stolen by Eve, for instance, from Bob? That's not a good authentication service. So that's why you need to have Sharon in the loop always wherever authentication is. Yes.
Or you can make it so Sharon is like a proxy, so you send it to Sharon and Sharon makes the request for the mail server for you, returns the final result.
Yes, but that would increase the. Oh, sorry. Yes, that's again a very good question. That would increase the load on Sharon's proxy, right? Like think of it this way, right? Sharon would become the bottleneck for this entire network in that case. You don't want that to happen because just for the sake of authentication, you probably don't want all the requests in the network to go through Sharon, right? Like not just bottleneck, it'll also add to the latency of every request. So yes, so yeah, we need to TLDR. We need to maintain Sharon in the loop wherever authentication request is actually made. So to mitigate the SSO issue over here, right, where you just have to punch in the password only once, we come up with something called a ticket granting server ticket over here, which is essentially you can think of it as a web cookie sort of thing where you punch in your password and your IDP populates a web cookie on your browser. It's something of that sort. Here, it's just that we don't have a web browser over here. We get a ticket granting ticket from Sharon again, which is this time encrypted with Bob's password, right? Uh, this way, we make sure that the password is never transmitted in plain text because Sharon knows the password, Bob knows the password. The only thing which happens is Bob makes a request asking Sharon for its ticket granting service, which Sharon already knows the password for because it's like the central authentication server which maintains the passwords for every client and every server. And once the encrypted ticket granting service is returned back to Bob, which is encrypted by Bob's password. Bob can punch in its password and extract the TGT from the encrypted packet. If at all Bob doesn't enter the correct password, or if someone tries to mimic Bob, he'll never be able to extract the TGT because they'll never know the path, right? So yes, with that, again, there's this program called KNet which runs on every client, which decrypts the ticket using the client password and so on. And so on. But again, there is one issue which still persists. As he mentioned, we still have the networks sniffing, which can happen over here, where Eve can just sniff the TGT from Bob once Bob reuses that TGT and can make a request on behalf of Bob. So we kind of try to bolster our ticket itself. We add the workstation's address as part of the ticket over here. In addition to username and service name, we also add the workstation address so that even if Eve tries to uh, sniff that particular service ticket over from the network, it still will not be able to make a successful request to mail server because the Eve's IP address will not match to Bob's IP address, and whenever mail server decrypts the ticket because of the mismatch of the IP addresses, it will just discard that ticket. So that improves our system a little bit, and then but then again, you can like, does anyone want to take a guess at what the issue might be here? Like, it's a very straightforward issue. Uh, and yes,
So just another man in the middle.
uh, uh, how exactly?
So if we have like, for example, if we're able to either put someone in between Bob and Sharon or between Bob and the mail server, we can still read the content.
Yes, but then the IP address would not match, right? Like, yes.
This would only work on a system where like each device has like one IP address. So if you have like a subnet or like
Sure, that's good. That's a good. I mean, you can think of this to be an internal system, like inside, like in a private subnet or something like that. But then, yeah, still, like even if we assume each network device has its own IP address, right? There's a very simple vulnerability here. Eve can just spoof Bob's IP address, right, and claim to be Bob. So yeah, and then okay, this way we have kind of improved our ticket with few additions. But then again, even if we forget about the fact of spoofing a web server, the workstation address for some time, there is still there are still few issues over here, right? The service ticket here right now, which is over here, because we use the TGT, right? We don't necessarily have to like keep getting a new service ticket every time we make the request, because that is offloaded by TGT, right? So here we can reuse the service ticket for mail server, which was issued to Bob, and Bob can reuse that for getting its mail, accessing its mailbox. So one issue which comes up over here is that because now the service ticket itself is not one-time use. It has like it can be reused multiple times, right? Eve can steal that service ticket from Bob and reuse that certificate directly to access Bob's mailbox, because Eve doesn't necessarily have to get a TGT and get a a service ticket from Sharon. It can like directly steal the ticket from Bob and just pass it over to mail server. And then because all of this is encrypted by the mail server's password, mail server would think that the request is actually coming from Eve, and Eve might be able to get access to Bob's mailbox. So to circumvent that, what we do is we add a few more parameters to the ticket over here. We instead of make all the ticket is still reusable, we add an expiry to the service ticket here by adding a lifespan and timestamp over here, right? So we added the web station address, the lifespan, and timestamp. So yeah, and then but we actually did not solve the core issue yet, right? Because what if someone steals the ticket before the ticket was expired, right? So these tickets usually have a lifetime of maybe like few hours, and then like few hours is a long enough time for someone to steal the ticket, right? Uh, so uh, so yeah, so the core issue still exists because someone can steal the service ticket before the it gets expired. So yeah, like, do we have any questions up until now? Because well, like this is a very straightforward system up until now, I believe, right? Like you can draw a lot of parallels from the web cookies and stuff like that. But yeah, If there are no questions, I'll probably proceed. Okay. Uh, okay. So a little inspiration from Hamlet over here. In the play Hamlet, uh, the there's a castle named Elsinore where two guards, change their duty. There's a guard named Francisco who was relieved by Bernardo. But how would Francisco know that the person who's coming in is actually um, a guard who will be taking his place and not an enemy, right? Like there should be some sort of uh, mutual secret which would be shared between both these parties, right? This system kind of takes some sort of inspiration from this, secret sharing between two parties involved. Because right now, if you look up until here, it's just Sharon who is giving tickets, and Bob is the one just relaying tickets. But as such, there's nothing which is actually shared between the mail server and Bob. Because there's nothing shared between the mail server and Bob, Eve can just steal that ticket and replay that ticket to get access to Bob's mails. But then to actually make sure the mail server is only accessed by Bob, we need a ticket. We need something which is common to both the mail server and Bob over here. So that's where we'll be introducing a session key, which is like used in a lot of other uh, systems as well. But then again, we need to make sure both the mail server and Bob have the same session key. And how would that happen? Uh, so of course, because we have Sharon would be the one who would be issuing that session key. And the problem over here is we need to communicate that same session key both to Bob as well as the mail server. That's not a trivial problem because it's a distributed system, and then you can't just spam the mail server and Sharon for every request which is made to the mail server. So instead, we kind of come up with a very clever approach, I would say, where we don't spam any of these servers, and it's the client which does this heavy lifting. Again, the core idea which is to be kept in mind is the session key which will be shared between the mail server and Bob. Instead of just sending the mail server's ticket, whenever Bob requests for a ticket for the mail server, Sharon would respond with a session key, which is not encrypted with the mail server's password, and the ticket itself is updated with a session key. If you look at this, right, we have prepended a session key to the ticket. So this way, Bob kind of uses. Just keep in mind that the session key is not communicated with the mail server yet because this response is from Sharon only to Bob, and it's Bob's responsibility to communicate this session key to the mail server correctly. So the way this happens is that again we can't just pass this on directly because if you do this, we can that you are still vulnerable to the man in the middle attack. So what Bob does is that it fabricates something called an authenticator, right? So okay, why does a man in the middle attack happen over here? Because this session key is unencrypted. It's like in plain text. So if someone gets a hold of this, uh, they can just replay all of this using a man in the middle attack. So to circumvent that, instead of Bob directly passing on the session key, Bob creates something called an authenticator. So it kind of creates another ticket, like sort of ticket, with very few fields, as in the username, workstation address, the lifetime, and the timestamp, and encrypts this with the session key. So now you have two things. One is the authenticator and the service ticket, which is actually encrypted with mail server's password. So Bob now actually sends this authenticator and the mail server password to the the mail server, and mail server uh, decrypts the session key. It can't decrypt the authenticator right away because it doesn't know what the session key is, but it does know its password, so it'll be able to decrypt this part and extract the session key from this. And then once it extracts the session key, it'll be able to decrypt the authenticator. And once it decrypts the authenticator, it'll try to tally the username and both these tickets, the workstation address, the service name, the lifespan, and the timestamp. Of course, you can have like the lifespan of this ticket can be different from this, but what actually matters is tallying the username and the workstation address. If one of these don't match, it will essentially mean that the ticket is hampered in the process. So essentially, authenticator is a way for the mail server to know that the ticket was actually sent by Bob, and the service ticket is a way for the mail server to uh, know that the ticket was actually created by Sharon. If you have like someone else mimicking Sharon and someone else trying to be Sharon, the mail server, neither the mail server nor Bob should accept any tickets coming from that. So that's how we kind of try to secure the system from man in the middle attack and making the system secure. So yes, well, I guess. Uh, there are a few more intricacies here. Like, obviously, there's only the authentication is only one way here, where Bob is authenticating to the mail server, but we also need to make sure whenever Bob is communicating to the mail server, it's actually the mail server which Bob intends to communicate to, right? So you need to have some sort of mutual authentication as well. So essentially, all of this, uh, uh, which we discussed, will happen the other way as well for the mutual authentication, the other side. And then uh, we talked about the session key, right? So the ticket granting ticket is also associated with the session key because like if someone gets a hold of ticket granting ticket, they can still uh, uh, work around all of this to get service tickets for someone else. So once we have the session key associated with the ticket granting ticket, it'll make the ticket granting ticket secure as well. So we have secured the ticket granting ticket, we have also secured the service ticket, and we have made sure we punch in the password only once, which achieves our SSO objective. And then what else? Um, uh, I guess yeah, and then we maintained passwords only in one central server, which makes the password management simpler. So yes, I guess that's covers the most of the basic objectives or design principles of an authentication system. If you look at it, various other authentication systems which live out there, right? OIDC and MTLS and TLS, they kind of try to do something similar, but this is a very legacy system. And although it's legacy, it's used in production systems at a lot of fintech firms because it's a very mature system. And it inherently supports a lot of traits of authentication like tenant isolation and stuff like that, which we did not cover as part of this talk because this was just a basic overview of the actual core system as such. But then, yeah. Well, so we kind of designed a secure system until like one of us finds a vulnerability, and essentially the character Sharon is essentially Kerberos. It's the key distribution center in Kerberos world. And then I would highly recommend if you guys have time to go through this dialogue, which is uh, which was published by MIT, where uh, they talk about this design spec in a way of a play, where they have a dialogue between a junior and a senior working at a IT firm, and then they kind of have this good cop bad cop sort of dialogue where each of them tries to challenge the other person, and they kind of come up with a system like this. So this entire deck was inspired by this. So I highly recommend you guys to take a look at this if you guys have time. And then yeah, like this again, this one thing which I would like to share here is that this was one of the best design specs which I've ever come across. Because it's a very unconventional design spec, but it takes into account a lot of things which a design spec should take it. So yeah. Well, I guess that's it from my side.
Thank you so much, sorry, oh my god. Thank you so much, Mohammed. Do you guys have any questions for Mohammed before he steps off the stage? That was a pretty good presentation on Kerberos. No?
Yes.
Is this design similar to what is like the state of the art nowadays?
State of the art
Uh,
for authentication systems.
yeah.
Yes. But there's one thing which is the reason why Kerberos is not widespread. It is because all of this relies on a central authentication server in a distributed system, right? Where you have like services from two different entities interacting with each other. You might not want to have a central authentication system which does both of these. So this is primarily for networks which live inside an organization. So that's the reason why we have protocols like OIDC and MTLS, which are much more prevalent in these cases. But like if you have to, worry about authentication in an organization's network, Kerberos does a really good job. Yeah, that's a good question. Yeah. Yes.
To what extent do you have to work with, like, say, the Kerberos protocol directly while you were an engineer?
Yes. Multiple times.
Like, I guess to what extent and in what sort of way?
One thing which I can think of is, whenever you design a service, right? Uh, uh, Very often the service itself is a client to another service, right? So you need to mount Kerberos key tabs for both the client and the server on the same service, because the service itself is a service for other clients and it will be a client for other services, right? So we had to deploy this in Kubernetes, and then we had to mount those secrets, those key tabs on this thing. So yeah, that was yeah. But then as far as core issues with the Kerberos authentication itself is concerned, I don't think we ran into a lot of those issues ever, because firstly it's open source and very mature system. So unless you and then because you reuse those tickets multiple times, the load on the key distribution center, the KDC, which is Sharon in our presentation, it's not that much. So it's like it's a fraction of all the traffic. And then if you horizontally scale it, you can also get rid of the single point of failure, right? Like you can distribute that into 3 or 4 replicas, and then read all of them reading from the same database.
Do any of those shared replicas need to share state?
With state.
Any of the replicas of the Kerberos servers?
When you say state, you mean database?
Yeah, I guess I guess they'd be all running the same database service then.
Yes, they have to write to the same database service, and then you can have like active passive replica of the database itself. So like if one goes down, you can have the other one.
Makes sense. Okay. How does Kerberos relate to other protocols like OAuth?
Firstly, Kerberos is an authentication protocol. It's not an authorization protocol. OAuth is an authorization protocol, which was created by Google and Facebook. And on the other hand, OIDC is a wrapper over OAuth, which does the authentication. The one very stark difference between Kerberos and OIDC is that Kerberos works very well in an internal network because of Sharon and like KDC. But then, like when you actually have a true distributed system where you have services from different entities interacting with each other, you can't rely on one single thing. So that's where OIDC comes in, and That's where the OIDC handshake happens, where it's like the core idea is similar in terms of like here we brand the secrets as tickets. In OIDC we brand it as tokens and cookies. So yeah, like, but the core idea is similar, more or less.
That makes sense. Okay.
Yeah.
Thank you.
Thank you. Thank you guys.